Next question, question number 12. Now see, that also belongs to the same module, that is advanced math, and it belongs to the non-linear equation in one variable and the system of equation in two variables. Okay, now have a look. Question number 12 is saying, in the xy plane, a line with the equation this intersects a parabola at exactly 1 point. Okay, so they are saying we have a parabola, okay, and we have a straight line, because see, this is the equation of the straight line, and they are saying we have another graph as parabola. So they are saying it intersect exactly at 1 point. So let me just put down some stars here that they intersect exactly at 1 point. Okay, now the question is saying, if the parabola has the equation this one, so this is the equation of your parabola. Okay, where of course b is a positive constant, so we have to remember that b is a positive constant. Then in such scenario we have to find the value of b. Okay, now considering all this data, the question is saying we have a straight line. Okay, so straight line is, let me just write down the equation of a straight line is what it is, 2y is equals to 4.5. That means, can't I say the equation is y is equals to 4.5 by 2? Okay, so 4.5 by 2 would be what? It would be 2.25. Okay, so this is the equation of my straight line. So I'm going to mark this one as my equation number 1. Okay, now another thing is what? Another thing is my parabola. So we also have the equation of parabola. No? So the equation is y is equals to minus 4x square plus bx. Okay, so this is the equation of my parabola. So I'm going to mark this one as my equation number 2. Okay, now the question is saying these two curves will intersect at only one single point. Okay, so if it is so, can't I say for that point of intersection, the equation of these two curves would be same, isn't it? Of course, because they are intersecting at that point. That means what? For that point of intersection, both of them will satisfy the same equation. Okay, so we can say, or we can say the point will satisfy the equation of both of the curves. Okay, so we can say at the point of intersection, let me just write down this thing here for you. At the point of intersection, both the curves will be same. That means what? My equation 1 equals to my equation 2. So that's what happens at the point of intersection. Okay, now if I do so, equation which suggests, equation 1 suggests y value is what? 2.25, and equation 2 suggests y value is what? Minus 4x square plus bx. So can't I say that 2.25 is equals to what? Minus 4x square plus bx. Okay, now have a look. If I just take all of these things at one side, so will it form a quadratic or not? Of course, because see, the curve is parabola, but the function, the equation is what? Quadratic only, isn't it? So let's just take everything at one side. So I'm going to have 4x square minus bx plus 2.25 equals to 0. Okay, so I'm going to mark this as my equation number 3. This one. Okay, now have a look on the statements given to you in the question. See, they are saying there is a straight line and there is a parabola. Both of them intersect at only one single point. So at the point of intersection, we know like both of the equations will be true. That means both of the equation, like that point of intersection will satisfy both the equation. Okay, so let's just assume that the point of intersection is x comma y. Okay, so because we have only one single point, which is the point of intersection, that means we must have only one value of x and one value of y. Are you getting my point? See, the value of y we are having here is definitely 2.25. Why so? Because see, it is directly given by the first equation, which is straight line. Okay, so definitely the coordinates of my point of intersection can be x comma 2.25. Is it clear? Okay, because see, this point of intersection will satisfy the equation of both the curves. Now, so obviously the y value, either you take it from the first one or from the second one, but it has to be 2.25. Okay, but what about this x? So see, we have a quadratic equation. So if it has a quadratic equation, so definitely we're going to have two values of x. That means we're going to have two roots. Okay, but one logic is saying there has to be two roots. That means two values of x, and one logic is saying there has to be only one single value of x. So is both the things can be true? Can these two statements be true at the same time? Of course they can be. When they can be true, so see, we are going to have two different roots of x. That means two different values of x from this equation number 3. But the point of intersection suggests it has only one value of x. So these two things can be true whenever you have real and equal roots. That means we are going to have only one value of x. Okay, but it has to be, the quadratic one will have two roots, but there will be only one single value of x. So that can be true only when we have real and equal roots. Are you getting my point? Like how to conclude that? See, there is only one point of intersection because they intersect at only one single point. Okay, that's true. Now we have a quadratic because of this point of intersection. So there will be two different values of x. So how these two things can be same, can be true at the same time? See, only when the quadratic will have the real and equal roots. I hope that is clear now. Okay, now if it has real and equal roots, that does mean what? B square minus 4ac has to be equals to 0. Then only it is possible. Okay, so because we were looking for the value of b, so for finding the value of that b, the b square minus 4ac has to be equals to 0. Then only you can find such condition in which there will be only one point of intersection with two different roots of the quantity. Okay, so let's just do that together. So if I do so, I'm going to have minus b whole square minus 4 into 4 into 2.25. Okay, and that has to be what? Equals to 0. Now I have only one equation and I have only one variable to find out, that is the value of b. So can't we simplify that? Of course we can do that. So see, we are going to have b square minus, now it would be what? It would be 16 into 2.25. So let's just do that together. 16 into 2.25. So we are going to have 36, that is equals to 0. Okay, now if I just simplify that, so I'm going to have b square equals to 36. So obviously my b value, see, we are going to have two different values, plus minus 6. Okay, it would not be only plus, it would be plus minus 6. But have a look on the question. Is it saying that b is a positive constant or not? See, that's what I have underlined here. I have marked the star. So because the question is saying b is a positive constant, so here you have to neglect the minus answer, the negative answer, and the correct answer would be what? It would be plus 6. Okay, so that is how we can proceed for such kind of question. But this question is of course going to be the important one because it has so many logics clubbed in one question. Okay, so of course the correct answer would be b value would be plus 6. So that has to be your answer. So I have to feed the answer as plus 6 only. Okay, so this question number 12 is of course going to be the important one, because see, it has the concept of a straight line, parabola, quadratic, nature of roots clubbed together in just one single question. Okay, so definitely that's going to be an important one for us. Okay, so I hope this important question number 12 is clear to everyone. Clear? Okay, guys. So